Okay, some fun things that you can do with the law of cosines and law of sines and some of the rules that we get are areas of triangles now become just really easy to solve out. You don't have to be a super genius. So let's say we take a regular octagon. It got 8 sides. Okay, here's my regular octagon. And let's say that we want to find the area of the regular octagon. So the area of the regular octagon, if you look and you connect your all your different vertices and angles, you're going to notice that we get some isosceles triangles in here. Okay, how many isosceles triangles do we get? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8 isosceles triangles. Okay, so let's say that there's a circle that borders this guy. So let's take a circle and let's see if we can make it border. And if you can't draw this good at home, you're terrible. So here's my circle. Look at that, perfect. And let's say the radius of my circle is 9 inches. Okay, so the radius of my circle is 9 inches. Can we find the area of the octagon? Octagon. Can we find the area of the octagon? And the answer is yes. If my radius is 9, that means each spoke that I've drawn out here is going to be 9 inches long. So this guy's 9, this guy's 9, this guy right here is 9. And so if I know that I've got sides of 9s, and look at this, AC sine B, BC sine A. So if I take one of these triangles in here and just label it with some, like A, let's call A the middle, and then we can call this B and call this C, then I don't know angle A, but I have sides B and C. So I would use this first guy right here, and I can find the area of this triangle right here. And once I find the area of one triangle, I can find the area of all the triangles. So let's do it. We're going to take the area is equal to 1/2 B and C times the sine of A. Oh my, what's the sine of A? Well, we've got 360 degrees in a circle, and we've got 8 of those angles. So angle A would be what? 360 divided by 8? 45 degrees. Now just punch this into your calculator. And again, make sure you're in degree mode because we're working with degrees right now. So 1/2 times 9 times 9 times sine of 45. Which gives us 28.639 or 28.638 square inches. And then how many of those do we have? We've got 8 of them. So whatever this area is, which is 28.638, we just take this and we're going to multiply this number right here by 8 for the number of sides. And when you do that, you get a grand total of 229.103 inches squared. And then you're not trying to take half the base times the height and figuring out bases and heights. We just need 2 sides of a triangle and an angle in between, and we can get it done. The last guy that's related to all of this is Heron's formula, and Heron's formula is another way that you can find the area of a triangle. And I forgot some parentheses right here. So let's say we've got a triangle. We don't know what kind of triangle. We just have a triangle, and it can be any shape of triangle. It can be, who knows. It can be just whatever kind of triangle that you can think of. And if I take this triangle and I tell you that the sides of the triangle are 13, 15, and 18, and we'll call this triangle ABC, and we'll say that sides of triangle ABC are 13, 15, and 18. But they don't tell us where the 13, 15, and 18 go. They just say, hey, these are the sides of your triangle. What's the area? Don't panic. We can use the formula here. So what we're going to do is we're going to take it in two steps. We need to find S first. And S is going to be equal to 13 plus 15 plus 18 divided by 2. So 13 plus 15 plus 18 divided by 2 is 23. How easy is that? And then everywhere we see S in the area formula, we're going to put a 23. And then we're just going to follow my formula here. Follow the formula. Follow the formula. So 23S times S minus A. Well, 23 minus 13. Times S minus B. 23 minus 15. Times S minus C. 23 minus 18. Punch that into your calculator and you will get an answer, or you can punch all that in and reduce your radicals. So it depends on where you're working, depends on what you might see. But if we do 23 times 23 minus 13 times 23 minus 15 times 23 minus 18, you're going to get 9,200. So some places will have you reduce 9,200, have you reduce that radical, which will reduce down to 20 square roots of 23. And if you don't remember how to reduce your radicals, make a factor tree, or look for squares that multiply to make 9,200, or just kind of whatever your preferred method is. Some texts will go ahead and have you decimal that out. And if you do that, you need 3 decimal places. So 95.917. And 95.917 what? Well, units squared. Whatever it is that you're dealing with, inches or whatever. And that's Heron's formula. That's all there is to it. It's a really easy formula to use. It's not tricky. There's no look at the left hand while the right hand does something really wacky. It's just a straight up simple formula that can make a lot of your areas for triangles just not hard at all.